Yo, what's up, Serpa Squad? Tanner here, and in this one, I'll show you how I made my latest round of plywood enclosures. The design I'll use is pretty straightforward, and with minor modifications, you can scale it to whatever size you want to make. For this demonstration, I'll make 3 different sizes. On the small side, it's 60 gallons, and on the large side, it's 600 gallons. Without any further delay, let's get to work. For the shell of the tanks, I'll primarily use 1/2 inch thick OSB. OSB is a great option because the uneven surface allows for easy application of sealants. That said, you can use whatever plywood's available to you. I wouldn't recommend going any thinner than 1/2 inch though. First, I address the sides of the enclosure. I already cut them to size, but for the larger enclosures, I'll include side ventilation. You could do this on a smaller tank as well, but I didn't think it would be necessary for the builds I was doing. Anyway, I measured and marked for them accordingly. I drilled holes in the corners and cut these sections out with a jigsaw. I cut these so that the area on the bottom is much larger than the top. I did this to account for the substrate compartment. I propped these up with the back panel to make sure the pieces fit correctly. They were good to go. I applied wood glue to the edge of the back piece and clamped the corners together. I went on to drill holes for the screws with the countersink bit. This will prevent the back piece from splitting and embed the screw heads. I secured the pieces together with 1.5 inch long screws. I repeated this process on the other side as well. I'll add rigidity to the structure with 2x2s. I started on the sides. I put down some glue and situated the board. You'll notice that as I'm doing this, I have a piece of window frame. I'm using this to create a lip where a screen can be nested later on. I clamped the board and locked it in with 1 inch long screws. I did the same on the other side. Now I'll add the backboard. Again, I put down some glue, clamped it in place, and attached it with screws. The front board is the same length, but it's attached differently. I just lined it up with the others and secured it with 2.5 inch long screws. Then I went on to add the cross braces. I applied glue to the ends and locked them in with 2.5 inch long screws. I should mention that I measured and marked for everything earlier for consistent spacing. I repeated this entire process on the bottom of the tank to create the main structure. For the 60 and 210 gallon tanks, I used exclusively 2x2s to reinforce the OSB. In addition to that, the smallest tanks only needed a single brace. However, once I moved up to the 600, I used a combination of 2x2s and 2x4s. Anyway, from here, I applied glue along the 2x2s on the bottom. I placed a piece of OSB over this. I secured it to the frame with 1.5 inch long screws. In doing so, I used a roller to keep everything consistent and to make sure the screws were going into the 2x2 frame. Moving to the front of the enclosures, I have some common boards. These look nice when they're sanded and stained. I ran glue along the bottom 2x2 first. I situated the board and clamped it down. Then I turned the tank upside down and secured it from the inside with 1 3/4 inch long screws. This attaches it cleanly without leaving holes on the front. I did the same for the top board. Something else you'll notice is that I glued and clamped the top corners of the bottom board to the OSB to keep everything aligned. I'll add more boards to the front to frame in the sides. I put them in place. I made some measurements and drilled through the boards with a long bit. As I'm doing this, you'll see that the common boards on the front are slightly longer than the width of the enclosure. I did this to account for another piece of plywood I'll add later on. Anyway, I went back with a larger bit to create a counterbore. I put glue between the pieces and secured them with 4 inch long screws. I did this on the top first and repeated the same steps on the bottom of the tank. However, I used 6-inch long screws instead. For the large tanks, I'll use glass tracks to create the doors. To attach them initially, I used contact cement. I painted it along the edges of the common boards and along the underside of the tracks. I allowed the cement to dry and then I pressed the pieces together. As the name suggests, this causes them to bond on contact. Alternatively, you could use something like construction adhesive, but you'll need to clamp the track in place while the adhesive cures. I later decided to secure the tracks further with a nail gun. I assumed the cement would have been enough, but I wanted to add more strength just in case. I also added screws in the top track of the 600. The glass for this tank is heavy, so the integrity of the top track is really important. Better to over-engineer and not have a problem than the other way around. After that, I applied wood putty to the inside of the tank. I covered the seams and screw holes to make it easier to seal. I went on to tape the front of the tank to mask off areas I don't want to apply sealant. For that, your options more or less are liquid rubber, Pond Shield epoxy, or some combination of the two. Both materials are safe to use, dry quickly, do a good job waterproofing the setup, and neither give off toxic fumes when curing. However, there are some differences. Liquid rubber is easy to apply straight out of the container and is pretty cheap when compared to epoxy. With those pros come a few cons. Even though it's easy to apply, you'll need to add upwards of 8 layers to get proper coverage. This product is also weird in that it remains somewhat tacky after it's fully cured. This is only the case though when it's not in contact with water. If it's wet, this doesn't happen at all. So it would really only be an issue in a more arid setup unless you don't mind waiting for it to pass. I just wanted to give you a heads up so that you know what you're getting into should you decide to use it. The epoxy on the other hand does a good job with only 2 to 3 coats and has no tackiness at all once it's cured. That said, it's really expensive and application isn't as straightforward. You have to mix up the epoxy parts, which I find annoying. Anyway, I'll use primarily liquid rubber for these builds. I applied it to the tanks with a brush and roller. I used the brush in the seams and the roller for everywhere else. While I was applying the first layer, I put geotextile fabric in the seams over top of the rubber. Then I covered it with more. The fabric will absorb the rubber and create a strong seam. The seams are typically the weakest link, so making them as strong as possible is important. From there I continued to cover all the wood. Now that the tanks are sealed, I can address the side ventilation holes. I secured a sun-blocking screen over the hole with stainless steel staples. This is a really fine screen that will allow airflow without creating exit points for the cleanup crew. You'll also notice that I applied liquid rubber to some of the tank's exterior. I wanted to create overlap to ensure the edges of the OSB are protected. I cut off the excess screen after that. From there I applied contact cement to the sides of the tank. I also applied it to pieces of 1/8 inch thick plywood that's cut to match the sides of the tank. This will conceal the staples, the edges of the screen, and the OSB. As before, I could have used construction adhesive instead. In fact, that's what I did for the 600 since the side pieces are so large. I also added silicone along the edge of the screen and to cover the staples. I went back and painted the exterior of the tank with 2 coats of latex paint. This will help preserve the outside from external forces. The only tank I didn't do this for was the 600. I stained and sealed the wood instead. Another thing I did for the larger tanks was attach casters to the bottom. This will lift them up off the floor and make them easy to move. If you add these, make sure to put them on the frame of the tank and not the OSB. After that, I removed the tape from the front. Seeing them now, I didn't like how the glass tracks looked from the front. I decided to conceal them with a small trim board. I applied some glue and locked them in place with a nail gun. Before moving any further, this is probably a good time to do a water test. If things are done properly, all should be good, and in my case it was. Most of the construction is done, and now I can move on to the finishing details. I sanded the front of the enclosures to prepare the wood for stain. Like usual, I started with 60 grit and worked my way up to 220. I used a dark provincial stain that really brings out the grain. After that, I sealed it up with 3 layers of polyurethane. Now we can add the screens. I build these just like a window screen. They're composed of screen frames, screen corners, spline, and screen. In most cases, I'll use fiberglass because it's easy to work with. That said, use whatever screen is appropriate for your setup. To build them, I cut the frames and attach them together with the corners. Then I use a spline roller to secure the screen in the frame with the spline. I remove the excess and it's as simple as that. I place the screen in the recessed area on the top of the tanks. They fit perfectly. Then I made measurements for screws. I drilled through these markings. I removed the screen and put a dab of silicone over the holes. I went back and secured the screen with stainless steel panhead screws. I also secured the middle of the screen with stainless steel staples. For setups that need to retain a lot of humidity, it can be helpful to only cover a portion of the topless screen. I did this for the 600. I put a screen in the front and covered the rest with corrugated polycarbonate. I put down silicone and secured it with stainless steel screws. An optional feature that's beneficial for setups with consistent watering is to drill for a bulkhead. I added one to each of the 60-gallon tanks and the 600. You'll install it like any other tank by creating a hole with a hole saw. However, if you used OSB, you'll need to put down a ring of silicone prior to adding the bulkhead since the surface is uneven. Once it cures, it will account for inconsistencies and create a watertight seal like usual. What if you don't want sliding doors? Well, you could always frame in a piece of glass or other material with wood to match the tank. This is harder to do, but it looks great and in my opinion, it's a better option for smaller tanks. To start, I ran a common board through the table saw to create a dado cut for the glass to rest in. Then I cut these boards at a 45-degree angle on a miter saw. I clamped them to the front of the tanks to ensure everything matched up. Once I got the sizes dialed in, I stained and sealed it all with polyurethane like before. Once everything dried, I accounted for non-mortise hinges. You're not supposed to cut into the wood for these hinges, but I did anyway. Otherwise, there would have been a 16th inch gap between the tank and the door. I used a chisel to create indents. From there, I glued and clamped 2 of the corners together. I secured them with a nail gun and let the glue dry. After that, I nested a piece of 1/8 inch thick plate glass in the frame. Then I repeated the glue, clamp, and nail process from before. I let the glue dry. I went back and taped off the front for silicone. I applied it along the edge of the glass to secure it to the door and to conceal the exposed edge of wood. I smoothed it out and removed the tape. After the silicone cured, I went on to attach the hinges. I secured them to the door. Then I lined it up with the tank's opening and marked for the hinges with tape. I used these as a guide to make indentations for the hinges. I secured them and the doors after that. I marked for the corners on the door with tape to account for magnets. I used a Forstner drill bit to make indentations for neodymium magnets. I repeated this process on the doors as well. Then I used super glue gel to secure the magnets. I wiped away the excess and taped them down while the glue dried. When doing this, ensure the polarity is correct so the magnets function as intended. Finally, I drilled a hole with a countersink bit for a knob, which I attached accordingly. Depending on what your vision is, you can put these tanks on a rack or keep it as a standalone piece. I built a 2x4 rack and dressed it up for the 60 and 210 gallon tanks. This allowed me to have the canopy areas be separate from the tanks. This is nice because it makes everything look like a single cohesive piece, but in actuality it's modular. To keep with this idea, I put little trim boards around the tanks to frame everything in. As for a standalone tank, my recommendation is to make a canopy that's separate from the tank. That's what I did for the 600. I built it exactly the same as the tank, just on a smaller scale and with little doors. Having it as a separate piece is nice because it's easier to access the top or service lights. I also put a corner piece on the outside to make things look cohesive. Another thing you'll need to account for is the glass, polycarbonate, or acrylic. I personally prefer glass. As I said, I used 1/8 inch thick plate glass for the 60 gallon tanks. I used plate glass for the 210 as well, but these pieces are 1/4 inch thick. As for the 600, I used 1/4 inch thick tempered glass. These pieces are much larger and tempered glass is stronger. I had to custom order these from a local glass shop, and all the others I cut myself. I used showcase locks to keep them shut. When it comes to the sliding doors, I'll need to include a handle. I repurposed handles from an old aquarium lid. I cut them to a smaller size and siliconed them to the glass. They're fairly discreet and easy to use. Something else worth mentioning is that the glass track itself is sealed with liquid rubber on the inside of the tank. When I taped it off earlier, I made sure to leave this seam exposed so I could waterproof it. And that's how I built my new plywood vivariums. The 360s are for my new Caledonia geckos, the 210 is for my blotched king snake, and the 600 is a blank slate. On a side note, if you go off the deep end and decide to make something this big, go slightly smaller than as big as you can go. I made this as big as I possibly could and it barely fit into the animal room. Also, I highly recommend bolting it to the studs in your wall with a bracket. Better safe than sorry. I didn't do it yet because I'm not sure if this is where it's staying. Anyway, I tried my best to explain things so that it's easy to follow, but admittedly these are probably the hardest videos to make on the channel. Regardless, I'm really pleased with this round of tanks. They're definitely somewhat overbuilt, but that's how I prefer to work. You could easily build tanks like this with other materials, but I like the look of wood, so that's what I did here. Plus, all of the OSB was free because it came from a freight shipment. As such, the tanks are built primarily from reclaimed materials. I think I've said enough though. As always, I really hope you all enjoyed the video and learned something new. If you have any questions, let me know in the comments. I'll try my best to get to them when I can. Until next time, Serpa Squad, take care and peace.